To determine the electrical load for an auto painting booth, we need to calculate the power consumption of each component separately and then add them together. In this case, we have 2 exhaust fans and 10 fluorescent light fixtures. We'll start with the exhaust fans. We have 2 exhaust fans, each with a 2 horsepower motor. The cubic feet per minute or CFM per fan is 6,300. The total CFM is 12,600. The motor efficiency is 85% or 0.85 and the motor power factor is 0.95. To calculate the watts per fan, we use the following formula: 2 horsepower times 746 watts per horsepower divided by motor efficiency times motor power factor. Plugging in the numbers, we get 2 times 746 watts divided by 0.85 times 0.95, which equals 1563 watts per fan. Since there are 2 exhaust fans, the total watts for the exhaust fans is 1563 watts times 2, which equals 3126 watts. Next, we'll calculate the power consumption for the fluorescent lighting. We have 10 fixtures, each with 4 48-inch tubes. The tube wattage is 32 watts and the number of tubes is 40. The total wattage is 32 watts times 40, which equals 1280 watts. Now we can calculate the total electrical load. The exhaust fans consume 3126 watts and the lighting consumes 1280 watts. So the total electrical load is 3126 watts plus 1280 watts, which equals 4406 watts. To determine the current required, we'll assume a voltage of 120 volts. The current is calculated by dividing the total electrical load by the voltage. In this case, 4406 watts divided by 120 volts equals 36.72 amps. In conclusion, the total electrical load for the auto painting booth is 4406 watts, which will require a current of 36.72 amps at 120 volts. It is recommended to consult with an electrician to verify these calculations and ensure that the electrical system is properly designed and installed. Let's break down each step in more detail. Firstly, understanding horsepower and watts. Horsepower is a unit of power often used for motors. 1 horsepower is equal to 746 watts. This conversion is crucial for translating the motor's power rating into a usable value for electrical load calculations. Secondly, motor efficiency and power factor. Motor efficiency represents the percentage of electrical power that is converted into mechanical power. A motor efficiency of 85% or 0.85 means that 85% of the electrical power consumed by the motor is used to drive the fan, while the remaining 15% is lost as heat. The power factor is a measure of how effectively the motor uses the supplied electrical power. It ranges from 0 to 1, with 1 being a perfect power factor. A power factor of 0.95 indicates that the motor is using 95% of the supplied power effectively. Thirdly, calculating fan wattage. The formula to calculate the watts per fan is motor horsepower times 746 watts per horsepower divided by motor efficiency times motor power factor. This formula takes into account the motor's power rating, efficiency, and power factor to determine the actual electrical power consumed by the fan. Fourthly, total fan wattage. Since there are 2 exhaust fans, we multiply the wattage of a single fan by 2 to obtain the total wattage consumed by both fans. Fifthly, fluorescent lighting wattage. Each fluorescent fixture has 4 48-inch tubes, each consuming 32 watts. To find the total wattage of the lighting, we multiply the number of fixtures, which is 10, by the number of tubes per fixture, which is 4, and then multiply the result by the wattage per tube, which is 32 watts. This gives us the total wattage consumed by all the fluorescent lights. Sixthly, total electrical load. The total electrical load is the sum of the power consumed by the exhaust fans and the fluorescent lighting. This value represents the total power demand of the auto painting booth. Seventhly, voltage and current calculation. Assuming a voltage of 120 volts, we can calculate the current using Ohm's law, which states that current equals power divided by voltage. Dividing the total electrical load by the voltage gives us the current in amps. Eighthly, consulting with an electrician. It is essential to consult with a qualified electrician to verify these calculations and ensure that the electrical system is properly designed and installed. An electrician can assess the specific requirements of the auto painting booth and ensure that the electrical system meets all applicable codes and standards. Now let's explore some additional considerations for electrical load calculations. Firstly, voltage selection. The voltage used in the calculation, 120 volts, is a common voltage for lighting and small appliances. However, depending on the specific electrical system, other voltages such as 208 volts, 240 volts, 277 volts, or 480 volts may be used. The voltage selection will affect the current calculation. Secondly, conductor sizing. Once the current is determined, it is necessary to select conductors, wires, that are large enough to carry the current safely. The National Electrical Code, or NEC, provides tables, such as Table 310.15b16, that specify the allowable ampacity of conductors based on their size and insulation type. Thirdly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting the electrical system from overloads and short circuits. The size of the overcurrent protection device should be selected based on the ampacity of the conductors and the requirements of the equipment being served. Fourthly, grounding. Grounding is an important safety measure that helps to prevent electrical shock. The grounding system should be properly designed and installed in accordance with the NEC. Fifthly, disconnect switches. Disconnect switches are used to isolate equipment from the electrical supply for maintenance or repair. Disconnect switches should be readily accessible and clearly labeled. Sixthly, motor starting current. Motors draw a much higher current when starting than during normal operation. This inrush current can be several times the motor's full load current. The electrical system must be able to handle this inrush current without causing voltage drops or tripping over current protection devices. Seventhly, power factor correction. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction capacitors can be used to improve the power factor and reduce these problems. Eighthly, energy efficiency. When selecting electrical equipment for the auto painting booth, it is important to consider energy efficiency. Energy efficient motors and lighting can save money on energy bills and reduce the environmental impact of the facility. Ninthly, future expansion. When designing the electrical system, it is wise to consider the potential for future expansion. Providing additional capacity in the electrical panel and conduit can make it easier to add new equipment in the future. Tenthly, local codes and regulations. Electrical installations must comply with all applicable local codes and regulations. It is important to check with the local authorities to ensure that the electrical system meets all requirements. Now let's dive into the specifics of the components. Firstly, exhaust fan motors. The 2 horsepower exhaust fan motors are a significant part of the electrical load. Motors convert electrical energy into mechanical energy to drive the fan blades, which move air and remove fumes and particles from the painting booth. The power requirements of these motors are determined by their horsepower rating, efficiency, and power factor. Secondly, fluorescent lighting. Fluorescent lighting is commonly used in auto painting booths because it provides bright, even illumination. Each fixture contains 4 48-inch tubes, each consuming 32 watts. The total wattage of the lighting is determined by multiplying the number of fixtures by the number of tubes per fixture and the wattage per tube. Thirdly, voltage considerations. The assumption of 120 volts is a common standard, but the actual voltage used in the auto painting booth may vary. Different voltages such as 208 volts, 240 volts, 277 volts, or 480 volts may be used depending on the electrical system. The voltage selection affects the current calculation, as current is inversely proportional to voltage. Fourthly, current calculation. The current calculation is crucial for determining the size of conductors and overcurrent protection devices. The total electrical load is divided by the voltage to obtain the current in amps. This value is used to select conductors that can safely carry the current and overcurrent protection devices that will protect the system from overloads and short circuits. Fifthly, wire gauge selection. The wire gauge, or size of the conductor, must be selected based on the ampacity requirements. The NEC provides tables that specify the allowable ampacity of conductors based on their size and insulation type. It is important to select a wire gauge that can safely carry the calculated current without overheating. Sixthly, circuit breaker sizing. Circuit breakers are used to protect the electrical system from overloads and short circuits. The size of the circuit breaker should be selected based on the ampacity of the conductors and the requirements of the equipment being served. The circuit breaker should be sized to protect the conductors without nuisance tripping. Seventhly, grounding and bonding. Grounding and bonding are essential safety measures that help to prevent electrical shock. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of shock. Eighthly, disconnects. Disconnect switches are used to isolate equipment from the electrical supply for maintenance or repair. Disconnects should be readily accessible and clearly labeled. They should be rated for the voltage and current of the circuit they are serving. Ninthly, motor protection. Motor protection devices, such as thermal overloads, are used to protect motors from overheating. These devices sense the motor's temperature and trip the circuit if the motor gets too hot. Motor protection is essential for preventing motor damage and extending the life of the motor. Tenthly, lighting efficiency. When selecting lighting for the auto painting booth, it is important to consider lighting efficiency. Energy-efficient lighting, such as LED lighting, can save money on energy bills and reduce the environmental impact of the facility. LED lighting also has a longer lifespan than fluorescent lighting, reducing maintenance costs. Now let's address some common challenges and considerations. Firstly, code compliance. Electrical installations must comply with all applicable codes and regulations. The NEC provides a comprehensive set of standards for electrical installations. Local codes may also impose additional requirements. It is important to consult with the local authorities to ensure that the electrical system meets all requirements. Secondly, safety. Safety is paramount when working with electricity. It is important to follow all safety precautions and use appropriate personal protective equipment. Only qualified electricians should perform electrical work. Thirdly, permitting. Electrical work may require permits from the local authorities. It is important to obtain all necessary permits before starting any electrical work. Fourthly, inspections. Electrical installations are typically inspected by the local authorities to ensure that they comply with codes and regulations. It is important to schedule inspections and address any issues that are identified. Fifthly, documentation. It is important to maintain accurate documentation of the electrical system, including wiring diagrams, load calculations, and inspection reports. This documentation can be helpful for future maintenance and troubleshooting. Sixthly, troubleshooting. Electrical troubleshooting can be challenging. It is important to have a systematic approach and use appropriate test equipment. Only qualified electricians should perform electrical troubleshooting. Seventhly, maintenance. Regular maintenance is essential for keeping the electrical system in good working order. Maintenance tasks may include inspecting wiring, tightening connections, and testing overcurrent protection devices. Eighthly, upgrades. Electrical systems may need to be upgraded to accommodate new equipment or increased power demands. Upgrades should be performed by qualified electricians and must comply with codes and regulations. Ninthly, energy management. Energy management strategies can help to reduce energy consumption and costs. These strategies may include using energy-efficient equipment, optimizing lighting levels, and implementing controls to turn off equipment when it is not in use. Tenthly, sustainability. Sustainability is an important consideration for electrical installations. Sustainable practices may include using renewable energy sources, reducing energy consumption, and recycling electrical equipment. Now let's look at some specific considerations for auto painting booths. Firstly, hazardous locations. Auto painting booths may be classified as hazardous locations due to the presence of flammable vapors. Electrical equipment used in hazardous locations must be specially designed and certified to prevent explosions. Secondly, ventilation. Proper ventilation is essential for removing flammable vapors from the auto painting booth. The ventilation system should be designed to provide adequate airflow and prevent the accumulation of vapors. Thirdly, lighting requirements. Auto painting booths require bright, even illumination to ensure that the paint is applied properly. The lighting should be designed to minimize shadows and glare. Fourthly, grounding and bonding. Grounding and bonding are especially important in auto painting booths to prevent static electricity buildup, which can ignite flammable vapors. Fifthly, interlocks. Interlocks can be used to prevent the operation of equipment if certain conditions are not met, such as the ventilation system not being turned on. Sixthly, fire suppression. Fire suppression systems should be installed in auto painting booths to protect against fire hazards. Seventhly, signage. Signage should be used to warn of potential hazards and provide instructions for safe operation. Eighthly, training. Employees should be trained on the safe operation of the auto painting booth and the proper use of electrical equipment. Ninthly, personal protective equipment. Employees should wear appropriate personal protective equipment, such as respirators and gloves, when working in the auto painting booth. Tenthly, emergency procedures. Emergency procedures should be in place to address potential hazards, such as fires or explosions. These procedures should include evacuation plans and contact information for emergency responders. By considering these factors and working with qualified professionals, it is possible to design and install a safe and efficient electrical system for an auto painting booth. Remember to always prioritize safety and comply with all applicable codes and regulations.